good.
Following up. Roger, roll with planet. Body downside, speed off.
Yikes. You bet. Okay. We don't need any more of these.
All right, folks, you know the drill. You're our remote production crew. Let us know if you can hear us. And you should get 3 cameras, not 1, not 2, not 4. 3 cameras on the screen right now. We have another fantastic episode of NSF Live. When I look up this way, you know that I'm looking at chat because it's on a monitor that you crick in my neck when I read sometimes. That's why I have to ignore y'all a lot of the times. But it looks like we're 5 by 5, and we're ready for another exciting episode of NASA Spaceflight Live, our weekly live show where we do live things and talk about space news and stuff. And this is another cool episode here because we have a very special guest with us, Marcus House. How you doing, Marcus?
Hey, how you going, everybody? It's awesome to be here. Awesome to join you guys. It's just been such a crazy week, so I'm super happy to kind of wrap it up with just chatting away through this stuff. Awesome. Thanks, guys.
It has, and we've got an hour and a half here, Marcus, to talk through all the crazy stuff that's happened.
Yeah.
So we will definitely be getting that. We're going to talk a little bit about Marcus here in just a second. If you are a fan of Starship, you probably already know who he is. But also with me over here on this side, we have Thomas Burghardt. Thomas, you're a regular. How you doing, dude?
I'm good. Always good to be back on NSF Live.
All right. So it looks like we've got 5 by 5s in the chat. And y'all, you know, if Michael needs to be if Thomas needs to be turned up some or Marcus needs to be turned down some, let me know in chat. Like, say it over there and I won't read it and we'll just continue on with the show because whatever. You want to drive this show? Well, you can't. I have to. Anyways, folks, again, this is our live show. We have all sorts of different topics to talk about today. Since we're live, we also like to be interactive. We're not here doing presentations, and it's time for the space news. That's not how it is. It's literally a bunch of space nerds who love space stuff talking about cool space things that happened this space week. They could say space one more time.
A lot of cool things.
It really is. Couple things really quickly before we get into the meat of it. We are live, like I said. If you have a question for us, you want to ask us a question, put it in the chat at NASASpaceflight. Just tag us. That puts it into some cool software that we've got, and we can actually bring those questions up, put them on the screen, and try to answer them. However, there are thousands of you watching, almost 2,000 to start here, and there's only 3 of us, and we only have 90 minutes to answer questions. So there's no way that we can get through every single question, right? Just be patient. If you ask us a question that has nothing to do with what we're talking about, we're talking about Starlink, and you ask about dinosaurs. Probably not going to answer that one unless it's like, could Starlink be used by dinosaurs? And I would say no, because they didn't have the terminals. Whatever. Anyways, also, since we're live, we also have super chats that come in. We do try to say thank you for the super chats on occasion, like this one right here coming in. CANP Railroad says hashtag a Marcus fan club. So CANP, appreciate you. Looks like we've got a Marcus fan out there. But we will be saying thank you to those super chats on occasion. Hey, also, thank you to the members as well. So if you're a member, monthly basis, you're through here, you like us so much, for some reason you put some sort of auto renew thing on sending us money, I'll allow. I mean, Marcus, you like that with Patreon, right? That's a thing. It helps us out a lot, doesn't it?
So, absolutely it does. Absolutely it does. People don't really get exactly how much, but yes, it really does.
It really does. So across the board, y'all, thank you for all the different ways you support us. What is this? Multi-Space Industries says, I got to read this, Das Thomas House Fan Club.
Covered all our bases there.
Covered all the bases there, exactly. So that is our plan here today. Thanks everybody for joining us. Let's start off by talking a little bit more about you, Marcus. If you're a fan of SpaceX, Starship stuff, a fan of space news, you're on YouTube, you've probably seen Marcus's videos. So tell us a little bit about what you do. Like, how'd you get into this?
Oh man, it's probably not that different to the way you sort of kicked off with a lot of this stuff. We were all very passionate about Kerbal Space Program for a long time. Did a lot of simulations and things, and I think the reason that I more got into covering SpaceX is because I was making these simulations with Realism Overhaul and some of the plugins for Kerbal Space Program, and making these sort of very realistic sort of landings on drone ships and stuff, and the enthusiasm for the SpaceX market just sort of took off. And before long, it was like anything I talked about SpaceX got loads of views compared to anything else I touched on Kerbal, and it just evolved into that. So yeah, and then before I knew it, we're kind of essentially a SpaceX channel. We're talking about the news each week, and yeah, I mean, it's an absolute blast. I absolutely love the topic. You know, the audience is amazing. What we're being able to cover here, and the enthusiasm and all that stuff behind it it blows my mind every week, and it's only getting bigger at the moment, which is even even more awesome.
What a problem to have. I mean, I'm going to give you the same sort of thing that I get all the time. Like I'm scrolling through here and you mentioned Kerbal, and it's like, where's the Kerbal videos? I thought you said that there were Kerbal videos. I get the same thing all the time where people are like, well, Das, you know, you used to do Kerbal. Why don't you do Kerbal again? I like Kerbal. Please do Kerbal. And there's so much going on. It's a full-time news just to talk about Starship, it seems, right?
Yeah, man. Like we're usually up. You know, I've got a great team, several other people helping me write scripting and stuff. You know, we've got young Brendan who does all the Starship diagrams. He's helping me out every week. And, you know, obviously paid work. Brenton and Adam doing editing with me and things like this. So I mean, it's bigger than me. I can't do it myself. It's such a huge amount to cover. So yes, appreciated all the guys that helped me out, as well as I'm sure you guys have got a big team behind you. So yes,
I think you and me sort of started off the same way. Like, you know, you were playing Kerbal and you're making videos and you start off editing your own videos and doing your stuff, and then it just sort of balloons out to more than one person can do. I was in the exact same boat, and that's when I started with NASA Spaceflight, because having a team behind what you're doing is a huge difference. Isn't
absolutely. Yeah, absolutely. You know, and if I could just quickly say, as far as I can see, you know, you guys are doing it better than anybody else. Like, you know, you've got such a huge number of cameras going all the time. You've got 24/7 live streams. You've got multiple cams down on site. As you were saying earlier privately, you know, you guys can just switch. If there's one camera not working right, you can just switch to another one that is. It's just mind-blowing, the stuff that you're trying to
cut his mic.
manipulate.
Telling the secrets. You're not supposed to release the secrets from the pre-show. We were joking earlier. We have all the different camera feeds, and if one, like at any given time, like there's two cameras that have problems, and nobody knows it because we just don't show those cameras while I frantically try to fix them. You can't talk about what we talk about in the Jeez, really. Anyways, let's hop into some of the space news here, and of course we're going to talk about Starship. Everybody knows SN10, what's going on, SN11. We will definitely get onto that, but let's start with some other space news really quickly, starting with the document that I'm supposed to click on here so that I can actually bring up links. There it is. Whew. Okay, I found it. This week, big announcements from, I guess, time zones closer to your time zone than to our time zone. Rocket Lab. So what is going on with Rocket Lab? Thomas, do you want to give us a rundown and we'll talk through that real quick?
Yeah, absolutely. So Rocket Lab, well, Peter Beck specifically has been making a habit of eating his hat recently on so many different things. First with electron reuse, and now he's done two at one go. He's gone, we're going to now make a bigger rocket that's capable of human spaceflight. Two things that he said Rocket Lab would never do. And but so they're launching this new rocket called Neutron that's going to launch no earlier than 2024. It's reusable. It's bigger. It's almost like Antares sized. And I'm just going to let the video show this because this is so awesome. This reveal video of him blending up the hat and eating it was so great.
I cannot believe that he got pieces of the hat and put them in a blender.
I mean, I don't know how I would have gone about eating a hat. I don't know if it was that, but I don't know if there's a good way to do it. So
we saw the video, right? We saw the sort of reveal video. Did anybody have, when first watching this video, any indication of where he was eating this hat? I paused it.
I completely missed it until after the fact. I was like, oh, he's just on this cool set and he's got the hat stuff. He's going to eat a hat. This is awesome. And then right here, you realize, oh my God, he's standing in a payload fairing.
Did you see, when you saw this video, did you just say, oh, wow, he's eating the hat? Oh, and then this happens and he starts backing off.
Oh, there it is. Oh, it's so awesome. It was so well done.
It's very cool. It's just like, it's so nonchalant the way he did it. It's like, oh yeah, it's just sort of sitting there, and and it's pouring out into like a martini glass or whatever you call it. It's all very upper class.
I think yeah, he does. It's like a martini glass or something. He should have put an olive in the side of it or something.
Yeah, I know.
I was gonna make a snide remark about, you said you were gonna eat the hat, not drink it, but then he got a little sliver out of it and actually like took a bite of it.
Yeah, I think we'll let it count. I think
We'll let
it's
it
more
count.
than enough.
So
But yeah, and actually something he said during that, obviously we're not playing the audio, but what he said was there's a lot of things at Rocket Lab that we said we'd do that we've done, and also some things at Rocket Lab we said we'd never do that we've also done. And I think that's just so awesome. The whole point of the video is like Rocket Lab delivers on what they say they're going to do, and now they're just taking the stuff that they didn't really think they were going to do and say, we could do that too. Let's do it.
we might as
And
well.
there's probably a lot of confidence behind them delivering on this because, like they said, I can't think of a claim that Peter or Rocket Lab has made as like, we're going to accomplish this goal that they haven't already delivered on. They've got Electron launching very regularly, and that's scaling up. They've got Proton now flying, or Photon, excuse me, not Proton, different rocket,
Different rocket.
subatomic particle, Photon satellites flying, and all this stuff. So, and bringing Wallops online and stuff, and this is super cool. And there's a lot of details that we can talk about this. Shameless plug. I talked to Peter Beck about this yesterday, and there's an article going up on NASASpaceflight.com after NSF Live with a whole bunch of quotes and detail on that. So I don't want to give everything away, but there's a lot of really cool stuff about this rocket and what it might be able to do.
Well,
Yeah,
I want to
awesome.
ask, how does this fit in? Like, they were always the small sat launcher, this custom, I was calling it like boutique orbits, where you need to go to a very specific orbit. You don't want to wait for a ride share or whatever. On another rocket, you have a specific place you want to go, and you want to go whenever you're ready to go, right? How
Right.
does this larger rocket fit in? Is this like a Falcon 9 competitor? Certainly not Starship. Where does it fit into the rocket mix that we have?
Yeah, it's somewhere between a Falcon. It's like a middle ground because it's not the same payload class as Falcon 9. And we talked about this. I talked about this with Peter. And the main purpose of Neutron is building these satellite constellations. So we're still talking about small satellites, but launching several at once. And so if you want to operate a few thousand satellites in a constellation, you can't launch all of them at once because you're going to need to spread those satellites across different orbital planes, and it's just not efficient to put some satellites in one plane, do a maneuver to get to another one. That's super inefficient.
Right.
So it's easier to spread them out across different launches. But if you do
Yeah.
that on a Falcon 9, the number of satellites per plane means you're going to launch a half-empty Falcon 9 every time. So it doesn't make much sense from a cost and efficiency standpoint. So they're sized this for constellation building and having dedicated flights to each orbital plane so you can efficiently and cost-effectively deploy a constellation of satellites. And that's based on all of the feedback they've gotten from their customers, which is include a lot of Pathfinder satellites getting ready to build a constellation and things like that. So that's kind of where they came on this sort of 8 tons to low Earth orbit class. He also noted when talking to me is like most constellations fit this bill. There's a exception if you look at Starlink, where he's like those satellites are in a very low Earth orbit, and thus there's way more spacecraft. So it's sized well for a Falcon 9 flight. But on this vehicle, Neutron is kind of more typically what they're looking at as far as future constellations, and I think it's something along the lines of Neutron will be able to launch 98% of all satellites they expect to be launched through 2029 or something. So
Yeah.
they've done their market research and determined that this is something that Rocket Lab can do, still serving that small satellite market, but doing a different type of launch service for constellation building. And I don't know. There's a very good chance that this will be very successful. I can totally see where they're coming from.
That's the thing I think a lot of people just don't really sort of get with this, and I must admit, because I did a little piece about this in my video that got released here just recently, and the biggest comment that I've got is, this is, why do it? Falcon 9 is more payload, and exactly as you've said, this can target a specific orbit. If you're ride sharing on a SpaceX Falcon 9, you're going to one place, and you've got not a great deal of choice in it. Obviously, they would take some weightings on board with everybody that was ride sharing. But, if Starlink are also if SpaceX are cramming a few Starlink satellites on there as well, like it has to go to a pretty specific orbit. And and the thing is that the market is much bigger than the launch market is currently. The satellite market's bigger than the launch market. So everybody's really trying to cram satellites up in any way they can, and this is just a better, just yet another offering. And the 8-ton payload is great. It's sort of a middleweight. Falcon 9's around 22 from memory.
Expendable 22.
Yeah,
When you keep it
22.
reusable, it gets down to like 15 and a half or something.
Yeah. So it's a good lighter weight, but still heavy enough weight to actually do something more useful with than Electron alone. So yeah, I think it's great.
Yeah,
Neutron is squarely in the what they're calling the Soyuz and Antares class, that 7 to 8 ton vehicle. Interestingly enough, this vehicle will be launching from Antares' own launch pad. They'll be sharing the exact same launch complex at Wallops Pad 0A, which is very interesting. And considering Neutron is launching starting in 2024, Antares currently flies about twice a year. There's an interesting dynamic there that I think I'm going to want to revisit in 2024 based on what Antares is doing, and Neutron's in that exact same payload class. It's got this built-in capability that they could support human spaceflight missions and like commercial resupplies and things, which is what Antares is doing right now. I could totally see how this vehicle can fit in the future.
Yeah. One of the cool things about this is it says launch on repeat, right? And they're talking about reusable first stage, landing on an ocean platform. Like all these things sound familiar, don't they? Even down at the bottom, look. I mean, straight up landing legs. It looks like there's 4 landing legs on the bottom, and they look very familiar landing legs, style wise, I guess. So it'll be interesting to see how this goes. Again, surprising. It wasn't that one of the things that Peter said, where it's like, no, we don't need a larger rocket, and then all of a sudden, I'm going to eat my hat on reusability, and then also, hey, by the way, at the same time, I'm going to announce this larger rocket, and oh, by the way, it might be capable of crewed, like human space flight. So very interesting things from Rocket Lab. Marcus, I got to ask, because I have no context of maps, right? I mean, I know how maps work, but how, if you were to try to go to New Zealand, how long would it take you to get to New Zealand?
Not a real long time. We live in Tasmania, which is the little state right down the bottom of Australia. So it's down the bottom right. So we've first got to take a flight to the mainland, as we would call it, which is an odd thing to think about. But yeah, so we've got to first take a quick flight to, say, Melbourne, and then we'll hop from Melbourne to New Zealand. I don't think we've got any direct flights here, especially with pandemic stuff, but you know, it's sure. Yeah. So, but I could get there a heck of a lot quicker than I could get over to Boca Chica. Put it that way, I couldn't be further away.
I mean, it's like if we wanted to go, because I've always wanted to go to New Zealand because they have the fantastic launch facility. It looks like a supervillain hangout on a cliff with like a whole thing, right? And I've always wanted to go over there, but you look at it and it's like 24 hours, 36 hours of travel to get there for us, for me coming from the East Coast of the United States. Is it like 6 hours for you? I mean,
I can't remember exactly what the flight time is, but if we were able to fly direct from Tasmania, which we have been able to do in the past in certain situations, it's probably only like a 4-hour flight. I know, like if we fly to Western Australia, which is in the opposite direction, it's about a 4-hour flight. It's about similar kind of distance.
Yeah, gotcha.
But if we've got to first hop to the mainland, obviously we've got to transfer, and it becomes a longer trip. But it's very close in comparison.
Yeah. Have you ever thought about, I mean, pandemic stuff aside, because we all know how that affects things. Have you ever thought about hopping over there to visit Rocket Lab? Or?
Oh, definitely. Yeah. I was actually in a bit of a live stream with one of the engineer guys at Rocket Lab the other day. So, I haven't actually spoken to Peter direct before, which I really should try to get onto. But I would love to come over for a quick tour and do a little video about that. It'd be great.
Yeah, Peter's fantastic. He was a lot of fun when he was on the show here. Definitely, I think you would have a fantastic time hanging out with him and just chatting about cool space stuff. So, Rocket Lab, I don't know if you're watching, even though we're not doing the show on you today. Maybe it would come across your desk, but anyways. So, also, I mean, Rocket Lab doing exciting things over there. Also in the news, we were talking about satellites. We were talking about constellations. We finally got Starlink L7. What are we calling this thing, Thomas? L7.
The one that the cursed Starlink mission is what I'm gonna call it from here on out. Yeah, after so many scrubs, myself and Chris Gebhardt down at KSC for this launch, and after all of this is the entirety of what we saw from the press site that morning. And well, let's see. I'm gonna see. Did we get to T plus 10 seconds? I don't actually remember.
Nice. Good job on the filter there.
Yeah, and don't mind me messing with the new filters that we're still kind of learning to track. T plus 14 seconds. That's how much we got. That's honestly more than I thought we did.
Goodbye, Falcon 9.
Super low cloud deck, but to be fair, that meant the sound echoed really nicely, so it sounded pretty good. And I hope that made it a little
Nice.
more enjoyable. But yeah, the point being, this mission did finally get off the ground. Starlink L17, 60 more satellites on orbit. Falcon 9 nails the landing, so back on a successful landing streak, which is always good after
Yeah.
the L19 failure. So that's good, and hopefully back on track for a bunch more Starlink missions. I mean, we've got another one coming up. Looks at calendar next Tuesday or Wednesday. It's some middle of this coming week. There's supposed to be another one from Pad 40, and then before too long after that, they'll turn around 39A for another because they've got all the way until April 22nd now for Crew 2. That's their next customer mission. So until then, they're going to fill all those gaps with reused Falcon 9's flying Starlink batches. So hopefully they'll kind of pick up that cadence again, and they're still aiming for that. What was it, 48 launches this year? Which I don't know if they'll reach that goal, but getting as close as they can is going to just be as many Starlinks as they can throw into orbit.
Yeah.
So
it's typical SpaceX fashion where they toss out some goal that sounds super lofty, and people are like, "Oh, that's crazy! You'll never do it." And well, okay, maybe they won't do it, but if you say 48 and you end up with 40 or 36, that's still a lot of launches. That's
yep, and more than they would have done last year. Last year they reached, it was either 25 or 26. I keep forgetting the number and then keep trying to go back and reference it. Mid-20s last year, which was a record for them. And if they can just push beyond that and keep trending in the right direction, I think they'll be pretty happy with that.
Yeah. And Marcus, you were saying, I mean, these are of course Starlinks. There's 60 Starlinks on these Falcon 9s. It's sort of the constellation thing. But when we were talking about constellations and Rocket Lab being able to launch constellations as well, I think it's important to say it's not just Starlink. Like Starlink may have some competitors at some point. Will they be competitive is another question. But what do you think about that? Like, do you think there are some other applications for these constellations?
Oh, definitely. I mean, there's so many other companies that are looking at doing it. Obviously, Blue Origin have been looking at doing it. Essentially, I think they're sort of looking to service Amazon with their own sort of network and things like that. And that's something I see as quite exciting. Obviously, there's the constant debate going on, and my comment threads are always kind of filled with it. This whole space junk debate and that sort of thing. And obviously, SpaceX is doing everything they can to make sure that they can have various systems in place to mitigate any of those, chances of these big sort of cascades of debris happening. But I think what a lot of people don't understand is it's not really at the altitude where, where these things are going to stay in orbit. Even if they fail to respond or something, they're not going to stay in orbit for decades. These things will naturally come down reasonably quickly. I find that whole thing quite interesting. One of the topics that I covered in my video just recently was the fact that they've actually moved the entire network. There's sort of a graph that this awesome dude does on Twitter, Elias Asili, I think his surname is, and he's basically got all the spacetrack.org data, and he's got it all plotted down there, and you can see all the Starlink satellites are actually stationed. They're all kind of remaining static. They're all in position, and then all of a sudden the entire network starts moving, like all the different branches of Starlink sats start moving, and that's really quite interesting to me that they've brought it all down. I think they've brought it down around 2.5 kilometers, which just throws everything slightly out what everybody thought it was. So that's really kind of cool.
Yeah, it really is. I mean, some of the problems we've been identifying is there's all these launch providers and all this new capability that's being built, and what the heck are they going to be launching? Like, we need to have missions, we need to have companies that are actually there to buy launchers from the small sats, and then the Neutron for Rocket Lab, and then just all the rockets across the board need payloads. SpaceX sort of has solved that themselves because they're launching their own Starlink satellites. So there aren't 50 other companies coming asking them for launches, but they're launching their own because they're trying to use that to finance some of their other projects, right? The Starlink internet service. And so coming up with different reasons to launch, orbital debris mitigation aside, it seems like that's going to be a very important thing to support all of these up and coming launchers and companies and stuff like that, right?
Yeah, absolutely. They're definitely well suited to it. They've got all the rideshare systems that have that they've sort of started advertising just a little more heavily, they're talking about costs as low as $1 million. So if you've, presumably that's for a limited payload mass and everything, but that's, it's super cheap compared to what you've been able to do that in the past. And it's really exciting to see those missions kick off. There was a few late 2020. I don't think we've seen a rideshare mission more recently, though, from memory. But yeah, it'll be interesting to see that market grow.
Yeah, absolutely. So, y'all, there's been a ton of good questions coming in here as we've been talking about things. So, I'm going to sort of roll all this together. I mean, we talked about the Rocket Lab announcement, Peter eating his hat, the Neutron, the new sort of, Thomas, can I say like medium class rocket? Is there like a
Yeah,
class?
medium lift, I think, is
Medium
what you would
lift?
give it. Yeah.
Okay. And then we're also talking about SpaceX launching Starlink satellites. So, let's grab some constellation rocket questions. Well, not anyways, Constellation, that's a different rocket.
A constel. Oh, well, Aries One fan club. Hold up, where's the poster? Here we
Where's
go,
the
right
poster?
here.
Is that like made of other smaller pictures or what?
Yeah, it's got a bunch of it's really tiny pictures of like the people that worked on the program made into one
Ah,
of the collages. It's a very cool poster.
gotcha. All
Feelings
right.
of the rocket aside, chat. This poster's cool, okay?
Pencil rocket is a good rocket. Let's grab a couple questions here, just rolling all those things together. And let's see here. So we know that Falcon 9s have grid fins, right? Whenever they come back,
Yes.
they get some of that aerodynamic control via the deployment of the grid fins. And did we know from Alejandro Gonzalez here, will Neutron have grid fins?
Yeah,
What's
there's
that?
been no mention of that. I think we're
Haven't seen any.
expecting. I mean, the vehicle is smaller than a Falcon 9 is, and Falcon 9 does use a lot of RCS thrusters for its initial control, especially obviously before it starts re-entering the atmosphere. I think Neutron, excuse me, is going to rely on that. I don't. There's no visuals of sort of aerodynamic surfaces on there.
Right.
But also keep in mind, and when I talked to Peter, he was very stressed that the original announcement comes after they had decided to build the rocket, not decided how to build the rocket. There's a lot of research and development going on. They had determined that the market exists, they have the capability to build this rocket, but they're still developing the engines for it. They're still developing exactly how the tank structures are going to work, all of that stuff. We have only got this one render because that's a very notional render. They don't know how many engines the first stage will have yet,
Right.
because all of that still has to get worked
Yeah.
out. So does grid fins appear later on? Maybe that's a question for a little further along development Neutron interview.
Hmm.
But
Gotcha.
I could totally see them solely using RCS thrusters. In fact, we were talking about engines, and he joked that a Rutherford engine might be better suited for an RCS thruster than a main propulsion system on a rocket the size of Neutron. I
Yeah,
don't think
yeah.
he'll actually be doing that, although that would be cool.
Who
But yeah, I
hasn't
don't. Yeah.
who hasn't done that in Kerbal where it's like, well, my rocket needs more control. I'll use mainsails as RCS thrusters. Right?
Yeah, no, that's
But
very
yeah.
true. It's going to be exciting to see what comes of Neutron. I think it's it's a design, as you say, that is going to evolve quite quickly. And yeah, this is really just the initial announcement of it. I'm most interested in seeing what is going to happen with the whole crew side of things. I mean, obviously you've got an 8 metric ton payload. What does that mean? You know, what could we see from a crew point of view? Is it more crew support? And this is something I haven't really managed to find out myself. Is it more crew support, or is it actually thinking about making some sort of crew, capsule? And that's something that we haven't seen a great deal about yet.
They're gonna
Yes.
3D print a
So-
space plane or something.
Well, so for context, the Soyuz 2, which currently launches the Soyuz crew spacecraft, has 7 tons to low Earth orbit. So
Yeah.
a crew
Yeah.
vehicle capable of supporting 3 astronauts is within the mass capability of a Neutron vehicle,
Yeah.
compared to some of the bigger capsules, Dragon and Starliner, which require some more powerful vehicles. And obviously, Orion's a whole different thing.
Yep.
But yeah, it is actually capable of flying crew. Peter told me that they're not currently developing a crew capsule or a cargo spacecraft for Neutron, but it's all about designing the vehicle from the beginning to have all the features a crew vehicle needs, the certain redundancy and safety margins that you build in, which are just different than building a vehicle that's only going to launch satellites.
Yeah.
And so they can have the rocket ready, get that to market for their constellation building, and then say, okay, is there a market for a new crew vehicle? And if so, let's get building on that and we'll launch it on Neutron. So it's more about keeping it on the table for the future.
Gotcha.
Yeah. Wow.
Let's grab some more questions here. This is from Anthony Machad here, and this is, of course, Kessler Syndrome. I know orbits are closely monitored, but isn't anyone worried about Kessler Syndrome with so many constellations in the future? So really quickly, for people who don't know, when you hear the term Kessler Syndrome, it's sort of a thought experiment about, you have a satellite up there, right? And you put another satellite up, and those two satellites crash together, right? And when they crash together, they create lots of little pieces. And then those little pieces go out and they crash into another satellite, which breaks into more pieces. And then those pieces go out and they crash into 10 more satellites. And then those pieces go out and crash into 100 more satellites. And all of a sudden, you have like orbital buckshots surrounding the entire planet because all the satellites are crashing into each other and breaking into smaller pieces, which then go on to crash into other things. So Kessler Syndrome is this sort of thought experiment about what happens if, like in the worst case scenario, we trap ourselves on planet Earth by crashing too much stuff in orbit such that we can't get past it, right? That's sort of Kessler Syndrome. So when we talk about this, we're launching all these new satellites, the smaller satellites, we're doing these big constellations like Starlink, or we have DoveSats or whatever, you know, you're just putting more stuff up there. Spent rocket stages, they don't get reused and they're in like a graveyard orbit or whatever it is that we leave up there. What happens if that gets out of control and sort of cascades and, you know, theoretically it could trap us on the planet? Well,
Yeah, you know, similar to the whole Gravity movie, I guess. For anyone that's seen Gravity,
yes.
you know.
So what do we think? I mean, we know that SpaceX specifically is sort of mitigating that. They say we have this avoidance software that we have, and we have the ability to move the satellites up and down if they need to avoid things. Other satellites have to do things like debris mitigation, where they're going into a non-standard parking orbit. It's like, this is out of the way of everything. We can just have it here when it's done, like a stage or something like that. What other things do we know that are going on to mitigate that problem?
Yeah, it
Just toss
certainly
that
is an
out there.
interesting one. It certainly is an interesting one. One of the other things that people may not fully understand is, you know, we've got good tracking of everything that's large enough to be tracked up in orbit, but and there's always smaller things. It could be just one nut off one, you know, and it can actually be an extremely energetic collision, even if it's just something as small as, you know, like a fleck of paint can actually cause damage to the International
Little
Space Station
screw
and
or
things like
something like
that.
that.
Yeah.
Yeah, and we've seen that before, and
Yep.
they've done. You know, if you ever want to learn a little bit more about this, look up some of the tests they've done. I think they've got like almost like railgun type things with vacuum chambers on Earth where they can fire, you know, accelerate things up to almost orbital velocity and smash them into other things just to see what will happen. And, you know,
Yep.
like a small nut or something will go through like a huge, big, thick sheet of steel. So, you know, these things, even though they're small, they can cause considerable damage. And so, yes, it's certainly something that needs to be tracked well. But yes, they can only track things that are so small. So there's
Yeah,
always the
yeah.
chance.
Yeah, and the other part of as far as mitigation, like you said, it's making sure satellites can have avoidance software and maneuver oftentimes autonomously, especially when you have thousands of satellites. You can't have a mission controller on the ground watching every single satellite going, is this satellite in the way of everything or
Right.
anything? So
Yeah.
the way SpaceX does is their Starlink satellites actually are autonomous and can detect a potential near miss coming that they can avoid with a maneuver. And we've actually seen that happen, I think, once or twice,
Yeah.
or at least working on making sure that's all working properly. So that's one big mitigation. The other part of it is, especially when you're talking about these constellations, they're almost all operating in a very low Earth orbit, which means that it's easy to deorbit them if they have some sort of like propulsion failure and they can't actively deorbit. They'll naturally decay before too long, so that gets malfunctioning things out of orbit pretty quickly.
Right.
As well as if a collision, God forbid, were to occur, that
Mm.
debris would be within a orbit that is also very easily decayed, and so you're not talking about destroying really high orbits where that junk's going to be there for years. More things about that would naturally decay on the order of weeks or months, which is sort of a damage control mitigation strategy that's being employed too.
Yeah, yeah, and a lot of people may not necessarily understand the different orbits and why they're different. But you know, if you have a cascade effect going on up around, say, GPS altitude or
Hmm.
or you know, geostationary, you know, that's a huge problem because they're very specific orbits that are needed for so many things.
Yep.
And you know, we could almost have like a shell around certain areas of our orbits that we need. So it's incredibly important that we don't do that. And you can sort of see, yeah, that's actually the
Yeah.
perfect thing to bring up. The
Yep.
perfect thing to bring up.
I
You
got you,
can
Marcus.
physically, yeah, you can actually see the geostationary orbit. It's very clear. There's that much stuff in it
Yep.
that it draws basically a nice clear line, and you can sort of see it's almost raised as well. So they'll do geostationary at different planes, different
Hmm.
inclinations, and that's you know, that's shown very clearly in that graphic.
Yep. And if we zoom in, so this is a website, y'all. It's stuffin.space, like just the stuff in space. And I bring it up because a lot of people look at this, and you can really clearly see these. This is the geostationary ring right there on the equator. And as you zoom in, you can see how much stuff, like where are the Starlinks, where are the space junk that we track. And you look at this and you're like, oh my gosh, we've made an absolute mess of space, right? But the thing with this, because a lot of people are like, oh, we shouldn't launch anything else. Look, this looks terrible. These dots are huge.
Right.
Okay. You're talking about this is tracking this little stage, and space is a really, really, really big place. It's certainly something that we worry about, but don't look at this thinking we've already trapped ourselves on planet Earth. It's not to scale. It's hardly
Yeah.
painted. And these things that you look at this website, we're not there yet. It's something that we need to be thinking about. And of course, the different companies that work on this always sort of have these plans into place to mitigate their stuff getting out of control, I guess is the right way to say it. It's something they think about. So another good question there. Let's see. I'm going to grab one or two more, and I'm always watching the time. You know how it goes. We've talked about, there's some questions in here that we've already sort of answered just in our discussions. The aliens will think it's a defensive shield. Thank you, Chris. Yes. Welcome to
all calculated.
Calculated our Earth defense shield. You can't visit Earth. We've put too much junk up there. No. I see some questions over here about crew rating and stuff for the Neutron, and other questions that we've already sort of answered. The class of Neutron is sort of medium lift, but if we've already talked about it, I'm skipping a couple of these. I don't really get this question, so let's talk about this before we move on. NASA spaceflight, will Neutron be used more like a Falcon 9 or more like Starship? Either that or somewhere in between. What do y'all think that means?
So Starship is such a unique vehicle, which obviously we're going to talk about next. That I'm not sure. I don't know if I can compare Starship to anything. I don't know. Marcus,
It is hard.
Yeah,
It is hard to
I
compare
mean,
that to anything. I mean,
mass to orbit wise, you can say, oh, SLS is the other super heavy lift. More than
yeah,
100 tons to orbit once you get the Block 1B upgrade or whatever. That's the
yeah,
only thing that really comes close. But I don't know. It's more like a Falcon 9 than Starship, right?
Right.
yeah. I mean, it's a more traditional rocket, of course, and it's using a lot of tech, or inspired by a lot of tech from Falcon 9. But in the end, Starship is so different in that, if the cost of mass to orbit with Starship is anything even close to what Elon Musk has suggested in the past, it kind of does disrupt the entire market to the point where we really don't know. We really can't
Mhm.
predict what that means for other launch vehicles, but it's still a long way away in terms of being able to deliver. And of course, they still have launch facilities that have to launch from certain locations. There are some advantages to Rocket Lab's location and
Right.
whatnot. So it is difficult to compare
Yeah,
anything to Starship.
we get back into the boutique or the concierge orbits or whatever you want to call them as well, because
Yeah,
Starship, even if it has a really low mass to payload, is still going to an orbit, right? And if you want to
yeah,
be going
yeah,
into a polar orbit, or you want to be going into a specific sun synchronous orbit, or whatever it is that your special orbit that your satellite needs to go to is, you can't just put it on a Starship and launch it and all right, we're done deal. I
exactly.
mean, I imagine, and we'll see what the actual numbers shake out to be, but could you say, oh, well, Starship is so cheap, is it still so cheap if I only need to launch 1 ton or 2 tons?
Right.
The mass to payload, or the cost to payload per ton, sorry, cost to
Yeah.
orbit per ton is a lot
Yeah.
different if you just want this one little satellite that's going to this one place. And how could you mitigate that? Could you build a lot bigger satellite that rides to Earth, rides to orbit on a Starship, and then it's got its own thrusters and fuel, and it flies to its boutique orbit from there using orbits or trajectories, transitions that we would normally say were really inefficient. But it doesn't matter because Starship is so huge, and it could just take an entire spacecraft to orbit, right?
Yeah,
Yeah.
and one of the
But
more interesting comments that I get as well is that people don't really fully understand the cost of some of these satellites. Like some of these
Yeah.
satellites are, many times the cost of the rocket. Like the full
Mhm.
Falcon 9, they can be many times the cost of the
Yep.
Falcon 9. So whether they spend 90 million on a launch or 150 million on a launch, it's not that big of a difference, because the
Yeah.
cost of the satellite may have been $300 million, something like that. So it very much depends on a case by case basis what's going to work out better.
Yeah.
Yeah, and I'll point out, and this is another bit from Peter. You said, cost per kilogram is a nice, easy metric to understand, right? But he doesn't know of a single launch vehicle that has ever been sold on a cost per kilogram basis. Whether
Yeah,
it doesn't matter how much of the payload fairing you fill, you still got to pay for the exact same cost to launch that rocket to orbit.
Yep.
exactly.
So that's that other part of it. So to answer the base question, I think the way to explain it is Falcon 9 was sized for the bigger satellites, things going to geostationary transfer orbits and
Yep.
things like that. Big DoD satellites, which are going to a whole bunch of different orbits. That's that sort of medium to heavy lift launch vehicle, which has
Yeah,
a side effect of being able to do rideshare missions like Transporter and Starlink batches and things like that. But
Yep.
that's not where the size originated. Neutron is not aiming to fly to geostationary orbit, or at least not big satellites out there. It's aimed at constellations going to low Earth orbit. It's just a
Yep.
different market, and so it's sized appropriately. Falcon
yeah,
9
yeah,
like approach to that, but a different market.
Yep. It's the same sort of the analogy I like to use is, oh wow, I can get a ticket to Australia, right? I could go to the airport and I could get a ticket to Australia and come visit you, right, Marcus? I'll just fly to
yeah,
Australia. It's
yeah.
easy. It's the
That's
same.
it.
Let's just go to low Earth orbit. But if I just fly to Australia, I'm still not going to be anywhere near your house. I'm going to have to get the rest of the way. I don't want to just go to Australia. I want to go to Tasmania and visit you at your house, right?
Mhm.
So
Yeah,
that's
yeah,
the difference between the smaller satellite launchers taking it to a very specific orbit versus just, man, look how cheap it is to get to space.
yeah,
Space
yeah.
isn't
That's
cheap if
exactly
you
right.
want to go to space.
I, I was going to say, the fact that they have specifically got a payload to Venus interests me. Obviously, Peter
Mhm.
Beck has got a big love of Venus. Did he talk much about that in your
Uh,
conversation?
on Neutron specifically, no, because I mean,
Yeah,
I think the idea is that that mission could be supported by Electron, because we're talking about only one photon, the interplanetary photon satellite.
yeah,
Of
yeah,
course, interestingly, they then went on to list the payload capabilities to Venus specifically when
yeah,
they announced Neutron.
yeah,
So
yeah,
maybe that's a hint as to a change coming forward. Although,
yeah.
if
That's what I was wondering.
Neutron's launching to 2024, and I think the first, at least the first Venus mission, maybe it's the first of many, is supposed to happen before that. So I think that's still Electron based. But
Right, right.
it's definitely capable of some higher mass missions to deep space. Totally. So
Yep.
um, we'll see.
Yeah, yeah, yeah. There's a payload mass for those people that may not have it on screen. There's a payload capability. It says there of around 1,500 kilograms.
Hmm.
Yep.
So yeah, that's still one and a half tons is still a reasonable amount to be able to get to Venus. Oh man, I'd just love to see some experiments there trying to drop things into the atmosphere and maybe
Oh
things
yeah.
that can just float at the right altitude to sort of
Right.
stay happy and report information back. Is there any way that any sort of life could be living in the clouds of Venus?
Yep.
It remains to be seen. There's a lot of exciting stuff to explore there that we just haven't been able to before. So, yeah,
Just all sorts of ideas like that. I mean, like we said, we need a reason to be in space. It's one thing to be able to go
Yeah.
to space, but we need
yeah,
things to do there. And whether it's orbital manufacturing in cislunar space, or whether it's exploring other planets or deep space probes or whatever, right? The more reasons we have to be in space, the more we'll end up there. Does that make sense?
yeah,
Like,
Yep.
exactly.
yeah. So I wanted to let me see here. One more thing. Let's talk about this really quickly. And Thomas, I don't know how much specific information we have on this, but it's a question about SpaceX and missing that stage one camera. We haven't
Oh
gotten any
yeah.
more information on why that camera is missing or what's going on there. Have we?
Right. And so this is the first time this happened, but on this Starlink launch, there was no live camera feed from SpaceX from the first stage. Normally they have that camera view kind of looking down the side of the rocket,
Yep.
that they just didn't have, which is mostly for webcast purposes. I mean, there is
Yeah,
engineering purposes to having those cameras on board, but it's not a flight item, as evident by the fact that they launched anyway.
Yep.
I remember a couple launches ago, there was a similar issue. They said we have a problem with it. Might have been a stage two camera, and they actually scrubbed the launch because they wanted to, not because the camera was missing, nice, but that they wanted to fully understand why the camera was not online, because it could have been indicative of some larger like electronics problem.
Right.
Um, so I think that also applied to this Falcon 9 mission with the first stage camera. Evidently, fixing the camera was not the problem. They just wanted to make sure it wasn't indicative of another problem, and
Hmm.
evidently it wasn't. They kind of ruled that out. So they said, all right, we're not going to delay the launch again, especially this launch being delayed so often, just to replace the GoPro or whatever they use. We can launch without it, and our webcast will be slightly less exciting as a result, but that's okay. You know.
Was it, so I was going to ask, and I didn't actually look up this information. I just asked you. Um, is it they've lost? They haven't had the first stage camera on multiple different boosters. So I'm trying to get to, is it a
Oh,
problem
is it
with
the same
cam-
booster as
yeah,
last
is it the
time?
same booster that didn't have the
Oh,
camera, or
you
is it like
know,
a
I'd have to
cra-
go back and check. I know they fixed it though before that launch,
Yeah,
so even if it was, I'm not sure I'd connect the two.
gotcha.
But I
I
do
was
not know if it was the same booster.
wondering if it was like a ground equipment or a ground link thing that was changing or different or something, or was it this camera link on this booster wasn't working, and so every time this booster launches, we're having trouble with it. Like that's what I was sort of wondering. But
There was live feeds from the second stage camera still, so I would imagine it wasn't like a ground telemetry link issue or anything. And they
right,
had telemetry fine. It was just the video that they didn't
it
have.
was
So it
just
was
the
probably
video.
specific to the camera.
Gotcha. Okay. So that was just another question I saw came through that we
Yeah, sure.
didn't have over the webcast. On the webcast, we had our view, which lost the rocket at
Which
T+.
lost the rocket
15
after 15 seconds, and
SpaceX
we just showed the
was a
launch
black
pedal.
screen, like.
Yeah.
So let's see here. Folks, I've seen the super chats come in. I'm going to say thank you really quickly. Graham, thank you so much. There was a question for Marcus in here. Marcus, are you doing this full time? Like YouTube videos, SpaceX updates, space news?
Yeah,
full-time gig?
it's definitely a full-time load. A full-time load. It's I am still working another role as well,
Oh,
3
wow.
days a week. So I'm doing 3 days a week at one location, and then everything
Gotcha.
else I'm throwing into YouTube. So yeah, it's certainly a full-time role. Plus, I've got the team helping me as well.
Yep.
The awesome Brendan and Brenton and Adam mainly working on that. Plus all the quality control guys that just volunteer some of their time to quality check things for me.
Yep.
So it's not just me anymore. It's a real undertaking each week to try to cover everything accurately. And we do our best to try to be correct with everything we say. We make the odd mistake, but it's
tough because it changes so quickly sometimes. You know,
Yeah,
one thing, and then they're cleaning up the nose cone or whatever. You know,
yeah,
so
exactly. I was almost going to use that exact same point. It's like, oh, they're going to keep this thing around, and then next week they're just trashing it. It's like, what?
it belongs in a museum, and then the forklift guy out there didn't get the memo.
Yeah, boom, and they're just that's exactly right.
I definitely feel you on it takes a full-time amount of work, but it's not a full-time job because you just got to pay the bills and stuff. So
That's
it is
right. Yeah,
so much work. Let's see here.
yeah.
Leon actually came through and said, glad to see Marcus House on the stream. Hey, Leon, thanks for saying hi. And
Hey,
here's
Leon.
oh no. I think this one's a troll, but I'm going to just roll the hand grenade into the room. Rough Rider said, great to see you, Marcus. When should we when are the KSP videos starting again?
Yeah, well, I get that one quite frequently.
Tell them next week. Be like next week, and it's just every time you ask, it's next week. It's your fault that I keep delaying this.
Exactly.
You viewer. Let's see. DRW Trippy, welcome. We've got some Starship SN10. We're gonna get to that. Here's a good one. This is from Danielle Stein saying, no matter how closely I follow spaceflight news, Marcus always tells me something new. Thank you. So well done, Marcus.
Thank you. No, we try to cover everything a little more in depth than what your general news article will be.
Yep.
As I'm sure you guys do. I mean, Thomas said before, saying literally talking to Peter Beck yesterday, getting all sorts of information there that wouldn't be out in the wild yet, and that's why we love the NASASpaceflight forums and news feeds and everything. It's awesome. You guys have got great access to this stuff.
Good deal. Let's see here. I've gone through a bunch of questions. A lot of the questions that are remaining in the queue, we already sort of just answered in the discourse of discussing things. So there was one other topic that we were going to hit on really quickly here, and then we're going to get on to Starship. Don't worry, we're going to be spending about half the entire show on Starship. But really quickly, we had a couple EVAs that happened up on the International Space Station, and there were some... I don't even know if hiccups is really the right terminology to use there.
Yeah, I think that's a fair term to use. I mean, it is not super normal. It's not unexpected, but what happened wasn't the usual, I guess. It's hard to describe it the right way because you don't want to like oversimplify things, but you also don't want to like cause a panic. Basically, pair of spacewalks, they actually just started. It's very interesting because the International Space Station is getting some new solar panels coming up in a couple of years, and these spacewalks were starting to get ready for those to arrive and get installed. And the first spacewalk, EVA 71, was Victor Glover and Kate Rubins both NASA astronauts out there, and during the spacewalk, a small tear in the outer layer of Victor's glove developed.
Yeah.
This isn't This isn't unheard of. There's a lot. They're obviously working with a lot of different materials. Everything that an astronaut does interact with over the course of a spacewalk is designed to not tear the spacesuit, kind
Right.
of a high priority. But
Yeah.
you're working on so many different things, it just can happen. Obviously, not a huge safety risk because there's a multiple layer thing. The spacesuit is designed to be a certain resilient material, and they kind of evaluated it and said, okay, you can finish your current task, and then you can head back to the airlock. You've done you've gotten enough of your tasks done today. We're still on track. Good to wrap up the spacewalk now, just to not push things further. And then similarly, the second spacewalk seemingly repeated itself. It was now Kate Rubins and Soichi Noguchi, so a different astronaut, NASA astronaut joining a JAXA astronaut. And once again, there's a slightly, as they described it, as like a pinhole in the glove of Kate Rubins' suit.
Right.
So this is kind of a slightly different issue, but the same thing where you have this problem on the outer layer of the glove. And it was actually interesting. They did wrap up the spacewalk a little bit early, but not as a direct result of the glove puncture. It was actually a sort of a limited consumable. I'm not sure if it was a battery level or something like that. There was some other limiting factor that actually prompted them to end the spacewalk a little bit early. They still got a lot done, and there's a whole series of spacewalks that these are part of that they'll be able to go back and make sure they get everything they need to do done. So it's not really a huge concern. Obviously, NASA will be looking very closely at the spacesuits, making sure that they can get those patched up or make sure they're still in a safe operating condition. But as mild safety concern, just to be keeping an eye on things. But NASA and the astronauts have a lot of experience with this. They know what's dangerous and what really isn't, and they can make sure they're still doing what they need to do safely.
You've just got to love the guts of these guys too. These astronauts. It's like Kate just says, "I'm mildly concerned about this puncture. I mean, in the vacuum of space, I'm mildly concerned about this. I'm mildly concerned." So I just love it. And we've seen so many examples in the past of where things have happened out on a spacewalk, and their suits will be puffing up, or they'll have issues with tears in eyes and all these sorts of things where they can't get the fluid away, and they just work through it. They work through the problem. They come back on board, and to date we've had minimal issues really with spacewalks, and you would expect that. This is probably the most harsh reality for the human body to be in, and we've never really lost anybody on a spacewalk ever, have we?
No, I mean there's been like close calls. I remember Luca, the Italian ESA astronaut whose last name I cannot pronounce, that had some sort of fluid within his spacesuit issue. I think about the famous Chris Hadfield spacewalk where the cleaning fluid got in his eye and blinded him, right? So there's like things like that are serious, but at the end of the day, resolvable. And obviously the astronauts train so often for all these different scenarios that they know how to keep their composure and make sure they can sometimes even just keep working through it, or otherwise just make sure they get back inside safely and kind of go from there. It really is incredible.
I think one of the thing that always pops to mind, like on ISS, you hear things about little glove tears or something like that. But the thing that pops to mind is one of the first, or I think the first spacewalk, the Russian spacewalk, where they actually exited the capsule for the first time, and the suit inflated, right? It puffed up, and he couldn't get back into the capsule, and he had to actually vent some of the air out of his suit so he could literally fit back through the door. This isn't the sort of thing where we just throw people into space, right? And no, we didn't think of that. They think about all sorts of stuff, and all the way back to that is the first example of something happening that they didn't think of. Right? It's like, or they didn't think of, they didn't even know that was going to happen. And so they tried it and they learned from it. And then we go forward. It's not, I don't normally hear things on like a NASA space flight or a NASA space flight. A NASA space flight walk. I cannot say NASA spacewalk. I can only say NASA spaceflight. It's just burned into my brain.
It's ingrained.
Yeah, where something unexpected happened, where it's like, wow, we didn't think of that. We're gonna have to come up with something,
Well, these EVAs were EVA 71 and 72 on the U.S. side, so 70 plus spacewalks under your belt, you're bound to know pretty much how these things can go and a lot about that environment. So there's a
Yeah.
lot of heritage and flight history to back everything up.
Yep. And
Yeah.
I wanted to bring this up because it was a thing. It's like, oh, they ended the spacewalk because there's a tear in the spacesuit or something. And it was the glove, and a regular glove check is a thing that the astronauts are trained to do. They know to be looking for that. Talking with the trainer out in New York at Intrepid Museum, she was actually showing us the different layers of the glove, and here's how we inspect it. And it's a completely normal thing to have to inspect this for little pinhole tears or something like that.
Yeah.
So not the end of the world when we hear news that there's a little pinhole. Hey, we found it, finished up, no big deal, right?
Yep.
All right. So that sort of gets us through all of our regular news topics. And so we go into our regular news topic, which is Starship SN10.
Starship.
And nothing happened with Starship this week, right? It
No.
was pretty boring.
Not at all. I don't even know where we want to start. So Marcus, Thomas,
Oh man, like
mean,
it really was just an incredible week. It really was, and it started off with a launch attempt that we thought was going to perhaps be happening on Monday,
Yep.
and it got delayed. So we had those initial weather delays, which for all of us that are watching so closely, it was like, come on. SN10 had a pretty good track record already. There was one Raptor swap out, one Raptor that didn't quite behave itself with some sort of issue that we still don't really clearly know what was wrong with that Raptor. It's just kind of an out of normal sort of range of whatever metric that they were looking at. But and then sure enough, up came Wednesday. And we were all live streaming this thing. I was live streaming my own stream, and you guys were going even longer. I think I did a 9-hour stream. You guys did like 11 or something.
we were right up against that border where YouTube stops archiving your stream if you stream too long. So we were like trying to wrap it up at the end of the day real quick.
It's like 11 hours and 52 minutes or something like that was the time we were pushing to YouTube. So, but
wow.
It's just I'm just gonna start playing videos, and if y'all want me to play a specific video, I've got the SpaceX videos. We can talk about the Raptors. Like there's so much to cover here. We never have a script or anything. We just sort of jump right in and start talking about stuff. But here is the launch. This is, I think, straight off of our live stream of the launch. This was Mary's camera, her view from over there, and I almost didn't believe when it lifted off. I was like, is it moving yet? I don't know if it's moving. Don't tell me that. No, I think I didn't want to say anything. I thought it was just an optical illusion and there was plumes of smoke, but it hadn't actually gone anywhere. But sure enough, it took off there after the initial, almost just a static fire where they had that last second auto abort, right?
Yeah.
So
yeah. And it's certainly interesting. I mean, it looked very similar, I guess, to SN8 and SN9. It took a very similar flight profile, almost identical as far as I could tell. And the most common question I keep getting is, why is it launching so slow? Why is it just kind of almost appears to just be hovering?
Yeah.
Very unlike a normal launch. And the main reason for that still seems to be that they're just wanting to get a good amount of test data from the Raptors, nice long flights. Presumably, and I don't know what the throttle would be set at here. So we've got 3 engines. Whether at this point we're seeing these Raptors throttling almost at full capacity, I don't know. Obviously, they shut them down as we progress through the flight. To keep the overall speed and velocities down and that sort of thing. But I'm not sure whether they're sort of throwing the entire force behind the Raptors in the initial launch, or whether they're kind of throttled right from the start. I'm not sure. Do we know any more about that?
I would think based on some of the back of the envelope math that you can do on this, I'm not sure. I don't think they can be at full thrust. I mean, we know it's the one thing they're avoiding so far has been going supersonic and reaching the kind of speeds that you're going to need when you start going towards space and orbit. And that's kind of where they're hitting that sort of minimal throttle that they can reach, and then they shut down a Raptor to cut their thrust again. Just so they can, because the priority of these flights is not the ascent, it's the descent. So I think I don't know, maybe initial liftoff in the first couple of seconds just to get away from the pad is pretty much full throttle, but I could see them throttling down quickly just to manage their acceleration and focus on what they need to be testing on these flights, which is that descent. So anything that can ensure you a safe and more a higher chance of reaching apogee successfully and reaching that belly flop maneuver is, I think, what the decisions that they make there.
Yeah. I'm just letting the video roll. I mean, you could sit down and play by play the video. I know we've done that like ad infinitum almost on what happened, but just some of the things we observed were, like you were saying, Thomas, shutting down the engines on the way up. That was all sort of planned. That was they don't want to. They were almost using that as a way to limit their thrust. I mean, not almost. That's exactly what they were doing. They were using it as a way to limit their thrust.
Yeah.
But we've done some of the math on here's what Elon says the full thrust of the Raptor is supposed to be, and here's what we think that Starship is supposed to weigh, and then are they at full throttle? Are they not when they take off? Like, we have some missing variables. Do we even know whether it was completely filled with fuel? Was it partially?
Right. Yeah.
filled?
We don't know what their fuel load is. We don't know exactly what the mass of Starship is and what thrust these particular Raptors could have been reaching. But I think if you even take some ballpark numbers and look at what the acceleration would have been on full throttle, it's not. It doesn't make a lot of sense for that to have been a full throttle ascent profile. So
Yeah, and they're really trying to just take it easy with these first few flights and make sure that they can get as much data as possible, I should say it that way. The one thing I thought was quite curious with this was the engine exhaust didn't look quite as consistent between the two engines. I didn't think, especially after they shut down one. One seemed to be running a little more maybe fuel rich or something like that.
Yeah, I can bring that up right here.
Issues.
Let's see here, because I know exactly what you're talking about. There was a definite color difference in right here, right next to me.
Yeah. One definitely seemed to have a lot more orange in it, so one seemed to be running fuel rich. And I wonder whether that had anything to do with the flames that we were seeing at the end. Whether there was just one leaking Raptor that was spewing out a little more, methane or something like that. Because and I'm still trying to figure out exactly the main cause for the explosion later down after it landed, obviously, because there was definitely something on fire. Whether that was related to the slight discoloration that we sort of see with one of the engines there is hard to say. We haven't had anything official on that, I don't think, yet. But I think, very interesting.
Let's see here. I'm just gonna keep rolling these things, right? These are just the videos, and let's go all the way over here to the landing. All right, not quite to the landing there yet, but I've got all the source video. I mean, we can roll video for days on this. Here we go. This is a little bit more, but you saw where they had one engine and they're falling, and then you see the engines ignite, and then we come in for the landing. We'll just watch that and talk through some of the landing. Of course, we all know, like, spoilers, right? We did land upright. SpaceX wants to use the term soft landed. I would like to use the term hard landed.
Right, yeah.
Like a marketing sort of thing there, right? But it was upright. It ended up not living for very long. I think it was like 7 minutes after the time that it touched down. It was vertical. It was leaning a little bit, but then it did subsequently explode. So we'll just watch through this real quick. And what were y'all's thoughts? Like, were you amazed that it even was able to land upright?
I think, well, this part we're watching now is the part that they've already nailed twice, which I think we're just glad to see that still being consistent and they're not finding new issues during like keeping control at this point. It's really that final landing maneuver that they're still really working on. And I think I'm not surprised that they've made progress and that they did have what was objectively a much more successful touchdown than the previous two.
Right.
But, definitely a step in the right direction, but also not surprising that it's not perfect yet. We do have, I
was going to say that you could actually see it probably better there in your stream than I had seen from other angles, but you could really see that flame there as it was landing towards the end. Quite a substantial flame, really. Maybe even bigger than I thought it was, and you can sort of see here. There. There's a lot of there's either a good leak going on there, or I think that's essentially what ended up causing the main damage after the landing. Anyway, the actual rough touchdown itself probably didn't help. They absolutely squashed those little baby legs. But
I mean,
Yeah,
this does clearly look like flames, and it doesn't look
Right.
like it's coming out from the side of Starship. It looks like it's coming out from the bottom of the skirt. So, Marcus,
Yeah,
like you were
and
saying, was there some leak underneath the skirt? Was the Raptor leaking? Like it wasn't supposed to shut down, but it was no longer igniting, but methane was still coming out? Was there some plumbing issues? Had it taken damage or something cracked or something like that? But a fair amount of methane seems to be coming out of the side here on fire. Not the
right.
side, the bottom.
yeah.
So what I'll point out is whenever you shut down a Raptor, when any rocket engine, to be honest, but including a Raptor engine, you'll see the flame kind of, I don't know, surge, if this is the right word, right at shutdown. It just kind of kick out some flames a little bit, which is pretty standard on just how a rocket engine shuts down. And it looks like that's kind of where the fire starts. So I don't know if that was just a result of nominal venting coming out from, because even during the flight, the vehicle does vent a little bit of its gases to maintain pressures where they need to go.
Yeah.
I don't know if that just got ignited by a Raptor shutdown, or if it was, a different kind of leak, because you see the engine shut down there for the final landing burn, and that's when the fire really kind of comes up.
Yeah, right
Yeah,
here.
So,
yeah.
I'll see if I can
like
pause
right
it
there, you've still got
right
two
there.
engines or three engines running, and then when they shut down those other two, that like a flame comes out.
Yeah, so this is
Yeah.
normal. Like we normally see
Yes.
a flame out like this when not a flame out, but you see a flame like this when they're intentionally
Right.
shutting down an engine. And I think the
Yeah.
interesting thing here,
Is
there's
that
still
that's
some
when,
flames.
and the fire kind of persists from that point forward.
Yeah, but the
Yeah.
curious thing is that the fire in this is sort of what I think I'm seeing. It looks like the fire is starting right here. It's almost like
Right.
you have raw methane coming out of the bottom and it's not ignited anymore, but then there's almost like a flame up here that continues to burn
Yeah.
down towards the plume that's leaking out of the bottom, right? I don't know if anybody else shares that interpretation of what we're seeing there.
Yeah, sometimes it could be hard to tell because when
Mhm.
methane's burning, it's almost quite transparent.
Yeah.
But then as soon as the mixture gets kind of messed up, then it can be brighter. So, but I was almost wondering if there was a leak for a longer period of time. Maybe
Yeah.
that
Mhm.
leak was actually occurring, and it may have been leaking into the exhaust, which may have been giving us that brighter exhaust on the ascent.
Yeah.
So if there was a leak always happening, and then of course as it's coming down, the leak's not going to be proceeding past the exhaust flame. It's going to be sort of coming out the side. So that's just a rough bit of speculation.
Yeah.
I wonder whether there was a leak the whole time and it was being initially ignited by the Raptors, just causing a bit of a color change in the exhaust, and then the exact same leak as what we're seeing here. I don't know,
Yeah.
but it's interesting. Hoping we find out more official
Yeah.
information on that.
Right.
I mean, you
I
get all.
there
Go ahead, Thomas.
I
Yeah.
was just gonna say there are two kind of parts of this failure, if you want to call it that, depending on how you define the successful test flight, of two things that we have kind of officially confirmed, or I guess not officially, but via our footage. It's very evident that not all of the legs deployed successfully.
Right.
Definitely.
But
I mean,
the
you can see.
you can see some of them, like you can see some of them come out and lock into place, and then other ones they like come out and then they kind of start dangling, like they
Yep.
didn't actually lock
Let's see which
in the
video
landing
that is.
position, which is not super surprising. We know that they don't really like the current leg design and that they're going to iterate on it. So to see that design has some issues and that we know they're already working on solving is kind of not is something to be relieved about, I would say.
Quick.
But the other part of this is, and this is one little bit of official information, and Das, we have a link to this tweet. Elon did give a little bit of information, although also admitting that they don't know everything yet. I'll
Right.
pull the direct quote is that the thrust was low despite being committed high for reasons unknown at present, hence a hard touchdown. We've never seen this before. And then talked about how they might mitigate that in the future. But there was also this thrust level issue that they encountered and don't, at least at the time of this tweet, which was last night, don't have an answer for or cause for. But that can influence two different things. First of all, when you touch down so hard, you're going to break things,
Right.
whether that's the legs or tank structures or whatever eventually let an ignition source to reach the fuel tanks and explode the vehicle. But there's also the aspect of if you're not decelerating at the rate you're supposed to be for that final landing burn, if those legs are relying on that deceleration force to
Yep.
force them to lock all the way into place, but you're not slowing down enough, that could have actually been the problem with the leg. Maybe the legs were just fine,
Yeah.
but because you weren't going slow enough, the legs didn't lock properly. So it's possible it's not even the legs to blame, and it's just this whatever this thrust issue is that they're going to be investigating. Obviously, it's
Yeah,
not
yeah.
surprising with these development Raptor engines that they're still kind of working out those kind of things.
Yep.
But yeah, so there's a couple different explanations here.
Yeah. So
And there was another little reply from Elon as well in regards to legs, because at first I must admit I was sort of thinking, well, you know, those legs, they didn't flip out properly. That was the reason for the harder than normal landing. What probably caused the explosion. Elon Musk did reply saying that the landing was way past the leg loads anyway. They got
Right.
massively squashed hard. So whether
Yeah.
all of them were out or not, I don't think it would have made that much difference to the end result.
Yeah.
That's not to say they didn't look strange. You know, several of them just kind of sitting there
flopping
flipping
around.
Yeah.
yeah, it looked a bit strange. Yeah, no, it was interesting.
Yeah, I'm gonna bring this up because let's talk about what happened after the landing, and we're gonna roll all this together and say what does this mean for SpaceX, right? We're just sort of reviewing the raw footage right now, but don't worry, we will get into talking about exactly what does this mean. I wanted to bring this up because this was one of our shots that we had from probably I guess it's our closest in camera, right? And so
Such a great
here,
shot.
oh gosh, this is before we've taken off, and I want to talk about the launch where we sort of see it going up. Marcus, you had mentioned that, and then we'll talk about the landing and specifically what happened afterwards. Let me go find that real quick. Sorry. So here, a lot of times we get these super tight zoomed in shots, and it's like, oh, I put 1500 millimeters on this lens, and then I cropped it 4 times, and it's like 8, whatever. But we don't always see the backed off shots like this, right? So in terms of how quickly Starship was launching, I wonder if this couldn't give us some sort of indication as to, well, it would help if I actually fast forward to the time where it did launch. There we go. This is something that you don't see as much of because we all love the super zoomed in shots, right? But Marcus, you had mentioned it looked like it was just sort of going up really slowly off the pad, like not accelerating at full speed. There goes a bird, by the way, getting out of Dodge.
It almost looks like we've got a SpaceX logo in the clouds there, just beautifully superimposed. If you
Elon
contrast.
spared no expense for the marketing there. But do we think that this is how Starship will fly more often? Do we think that they had spooled this down some just for the test? What are y'all's thoughts on this?
Yeah, it's still really hard to know how much it's being fueled, and a lot of people say, "Oh no, it's being completely fueled," because you can see the frost lines. You know, it looks like it's fully frosted. But it's like, well, no, that may not necessarily be the case because if you stick a heap of chilled liquid into a container, it's going to frost the entire container. Just because you may see a thicker band of frost where the actual cryogenic fuels are. Or the liquid oxygen is, but you may not necessarily get a real decent idea. So I don't think we can really predict the dry mass, the wet mass of this.
Right.
So it's hard to say. The Raptors, and we don't even know the full capacity of these Raptors they're using. These are obviously earlier prototype Raptors. Still, they're not. They're not in their final production. They're being iterated all the time. Is the max thrust of these Raptors still around that 200 metric ton? Capability? We don't really know for sure, and each one of these flights is probably adding new capabilities that none of us are aware of, but it seems to definitely be throttled to me. I think any way you run the numbers, the capability that those 3 Raptors have got are higher than what we see there. So I suspect they're probably they may be full throttle just on takeoff, and then maybe they back it off. But yeah, that's about all I think we know.
Yeah, it's just without having the exact numbers, it's hard to really guess anything like that. I mean, just because
we knew wet mass, we'd be able to calculate it, but we don't know wet mass.
Yep. I've seen people try to do all sorts of things like, oh, we know Starship is this tall, and then we paste this mini Starship, so it's accelerating this fast. But you still can't figure out the thrust of the Raptors from that, because if it was heavier, the Raptors would need to be at higher throttle or more thrust. And if it was lighter, then they could do the exact same acceleration at a lower thrust. Like, we just don't have all the variables that we need to be able to figure it out. But let's hop over here. I'm gonna miss this, like the first 10. Oh, well, that was close. Let's see here.
Not bad.
I think it's close. Let's see. It's so hard to find because it just suddenly appears in the frame. I thought I made a note of the time, but apparently I forgot what time it was supposed to be. And look at this.
Wow. It flips really fast. I don't know. I'd almost have to. Yeah, I'd almost have to have a look at the others to see if it flipped any faster than the others. But it seemed to flip real quick with those 3 engines this time.
Yeah. You can see, not zoomed in there, but you can see the fire coming up from the opposite angle here. But
Yeah,
that
yeah.
was the touchdown. And just look at how this thing.
If I'm not mistaken, and actually just looking at maybe the last second before touchdown, it almost seems to fall just a little bit to me.
Yeah.
Right at the end, it's almost like the engine sort of just started kind of stalling out right on touchdown. I might be wrong about that, but it just looks
Yeah,
like it just has a little bit of a drop at the end.
from other
Because
views, it
there
looked
it's
like it
just
might have actually bounced even, and that might be what we're kind of seeing.
Yeah.
yeah,
It's
yeah,
tough to. It almost did like the quintessential Kerbal bounce, where you come down and it land boing, and it like boings just a little bit. It does look
yeah.
like it had a little bit of a bounce to it, but just the thing that got me on this. I don't know if anybody else agrees with this, but look at this. Is it a trick of the light or a trick of the angle, or does it really look like it's coming down over here? A lot closer to the infrastructure than the actual landing pad, which is more over here. Like,
Yeah, well, I mean, it sort of has to do that because it's going to do quite a horizontal thrust and actually give it a
Right.
big push that way anyway. So it sort of needs to come down offset initially, which is kind of the scary thing because, of course, if it fails to fire up at all, then it's going to be landing, exactly where you've
Right.
got your arrow there. It's just going to plow straight into the ground. So it sort of needs to first thrust that way, which actually sends the entire vessel out that way, and then it's actually got to counter that and fire the other way for a bit, which is why you see this kind of weird S
yeah,
curve going.
it
Yeah.
is. It's like an S landing. I'd say VLC was messing up on me there, but it literally is sort of going down like this and then ending up over there and coming in like that. And
Yeah, yeah,
it's falling sideways. It needs to light the engines because we know via Elon that they use the thrust vectoring of the Raptors as the majority force to get that flip done, right?
Yeah.
So you got to
exactly.
start the Raptors when you're like this, and they're going to start pushing you this way. If you were coming down
Yeah,
straight over the pad, you'd end up over in the left-hand side of this frame here. But
yeah, exactly,
I don't want to
exactly.
see a situation where it's coming down on that trajectory and none of the Raptors light.
Right.
Yeah, yeah, yeah.
I mean,
And
the
you've got that exactly right there with the arrow pointing there. I'm not sure if they're actually offset, and it's a bit hard to tell from this angle whether
Yep.
they're actually offset
Yep.
outside of the facility, because that might be a slight angle as well. It's always hard with camera perspective, but you
Mhm.
wouldn't want to see it coming down straight over the top of the fuel farm before it
Right.
because if it fails, then that's not good.
I also point out that, and this is part of this new 3-engine landing burn, right? Is well, I don't know what the odds of all three failing to light are, and even if that in a scenario that would cause that, is that something that would get detected by the vehicle before the maneuver actually starts, and you would
Yeah,
activate a flight termination system at that point, right? I mean, there's
yeah,
Wow.
yeah, so it's you're not talking about I don't know if you'd find out all three Raptors are all of a sudden not working at the moment of ignition, and I guess that's what they're trying to mitigate with this new landing burn. So,
Right, right.
but yeah, I
yeah,
could totally see your point.
I really wonder, like, if it was coming down in that direction and if it's on one side or maybe it's a little offset, what we need to do is get, like, both the camera angles at the backed off shot like that and see if it would.
Right.
Well, we have,
yeah, yeah.
actually. We do have, let me see here. We've got it from this angle too. The advertisement for the Liebherr cranes.
Yeah, yeah.
See
And so you
here.
could probably work out roughly vertically what it's over before it starts to do that flip, and that would be an interesting thing to answer actually.
It actually looks like it's from this angle directly over the tank farm.
Yeah, which I mean they can't do that. I'm sure
Yeah.
that that's not the case, but if you look at it from a few angles, what are they actually planning on doing there? You'd almost expect that it should be hanging outside of the farm of the entire facility at this point, and then it sort of swings into the farm right at the end. But
Yeah.
it's like into the facility right at the end, I should say.
Here we go. I'm
Um,
I'm gonna draw a straight line on the screen here real quick. Let's see here. This so it doesn't when it lights the Raptors, it doesn't look like it's over the tank farm. It looks like, well, heck, now I've drawn the line. It almost looks like it's over the launch stand and then where sort of SN7.2 is, right?
yeah, yeah.
From this angle, from this one angle.
Yeah, it's really hard to tell. It'd be great if we could sort of see a bit of a top-down top-down shot of it, see
Yeah.
roughly what it's
Need
at.
to coordinate some satellite imagery on
I'll
this.
work on getting that robot deployed, Marcus.
Yeah, 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 yeah. Come on, what are you guys doing? We can do that, can't we?
Yeah. I'm just gonna let's see here, take a screenshot of this real quick like that, and then bring up the other view as well and just see what the other view looks like. I'm literally putting it in paint.net. What?
Yeah, I think one of the more interesting things about this, obviously, for those people that aren't as familiar with it, they did fire up 3 engines this time instead of just trying to fire the 2, and that was simply so they had an extra redundant engine if they needed it. But what was interesting was that engine 3 and 2, let's say we're firing them in reverse order, engine 3 and 2 shut off really rapidly. Like it was like bang, bang, both of them were gone. It's like, was the second one supposed to shut off that fast? I'm still wondering about that. I think that they probably
it's a little
were supposed to
interesting.
bring that. Yeah, I reckon they were supposed to have that second engine still going for quite a while, and it might have been why it landed a little harder. But Elon did say that one engine's got the capability to land it. But yeah, I'm still a little intrigued about whether it did sort of have a loss of thrust there right at the end, because it did seem to land harder than it looked like it was going to. It looked like it was coming down very stably there until right at the end it just sort of went boop.
Michael's going to kill me for showing that. Sorry. This is when we switched to the other cameras that we have. There was a bit of a rate problem there on the robot control. But what I was showing was the relight.
This shot.
And
which
Marcus,
is awesome.
look at this. This is off one of our remote control cameras.
Wow, that's a great shot.
God,
then
and
you
then
see-
the rate problem.
Right up until there.
We'll have that fixed for next time. Okay, it's just software. But then you emergency back out, then you go back in again. But you can see from here the landing legs sort of swinging back and forth, and we'll fix the pan problem next time.
Yeah, the best shot of that is probably the SpaceX feed, because they actually show the that you've got the pad cam looking upwards, and you can physically, you can quite literally, I should say, see that both of those engines pretty much just switch off straight away.
This is the SpaceX feed right here. Yeah.
Yeah. It's like
this
bang, bang.
camera
You
is
just see.
insane.
That camera's so nuts.
Yeah.
It's crazy. But it's like
there's one,
2.
there's another.
Like it's literally half a second away from each other. So I suspect that second engine probably was supposed to stay on longer. I don't know. It's just a guess. It seems weird to me that they shut them both down so rapidly like that.
Like if one of those engines was having an issue, they could keep. I would imagine the software would then say, okay, we're going to keep the other one that we were about to shut down on. Like I don't know. I feel like I'm leaning towards it's just this sort of isolated thrust problem rather than an early shutdown. I know, but I also agree that the timing appears weird and wouldn't be what I would have expected. So,
well, look at this. And who knows what the control software is doing, but when the Raptor shuts down, it gimbals full out, right? To sort of get out of the way, it looks like. In watch, both of the engines do that, I think. Let's see if we don't disagree. There's one, gimbals out.
One and out to the side, and then the second one
and out to the side.
Yep.
So is that the engine has detected that it's off and so it gimbals out, or is that a commanded shutdown? Hey, we want you to shut down, follow your program, which is shut down, gimbal out. I wonder.
Yeah. That's an interesting question. It certainly is. And like we also quite often say, there's nobody inside SpaceX giving us this information. We're all it's largely speculative when we're talking about this.
Roadside rocket science, am I right?
That's exactly right. Yeah.
Yeah, I think it would make sense because that third engine, which is now doing all of your thrust control, or your vectoring control, needs to be able to gimbal wherever it needs to go to make this landing happen. So when the engines are not firing, you just say get them out of the way so you can't have engine bells hitting into one another. This might be that.
There's probably quite a simple program there that says, if the thrust detected from this engine is less than this, then just gimbal out of the way, no matter what the cause of the thing is. So that might have just been automatic regardless of whether it was intended to shut down.
Safety takeover where it's like, okay, this engine's offline, get it out of the way, Maybe that's the way that software works.
Well, we sort of expect that's the way the legs work as well, whereas it probably just deploys the legs at a certain velocity. Because I know with SN8 or SN9, you did actually with either of them. I don't think you saw.
I don't think the legs deployed either time, right?
Yeah, it never got to the velocity needed that it was really going to land successfully anyway. Again, speculation, but I suspect that is probably the case, that these things are just automatic based on a velocity readout or something like that.
Yeah. Let's see. I'm going to go back over here because you've seen, right? The big thing about this is all the control that happens and all the success SpaceX had with getting this thing on the ground vertically. You can argue, is it a soft landing? Is it a hard landing? Or whatever. All right. They got it on the ground in basically like one piece, or like 0.99% of the Starship was still in one piece. Maybe some pieces came off earlier. So that was the important part. We've gotten this far without even looking at the explosion. But let's go and let's look at the explosion and just talk about that really quickly, not to detract from the important thing here, which is the third attempt for one of these high altitude flights. All right, high altitude, what? Just 10 kilometers, whatever. The third attempt, they actually have a vertical Starship afterwards, right?
Yeah.
We can jump to that.
At least for a few minutes. Yeah.
Exactly. Let's see here. There we go. So this will be the landing. And just the fact that they got enough control authority to make this huge, massive stainless steel skyscraper vertical on the ground. I get it, right? Like DCX Delta Clipper's already done this 20 years ago. The control for this isn't anything new, but that's a completely different scale, right?
Yeah,
sure. 20
that's
years ago, we were landing stuff like this, but it wasn't this size. It wasn't this massive Starship, the new engines, the new type of fueling, this stainless steel construction in the field in Texas, all this sort of thing. The fact that they took that and were able to apply the existing control ability to something that's this big, it's huge for SpaceX, right?
Yeah, definitely. It's a huge achievement to have stuck the landing on that. It's only the third attempt. People say, "Oh, yeah, but it still explodes." It's like, yeah, but you're not looking at the bigger picture. These are prototypes. They're rapidly developed. We've literally got one rolling down the road, possibly Monday, SN11. So, it's not like SLS where, one loss of a vehicle is like, years worth of work. These things are rapidly prototyped, and they want to fail quickly and fail hard when there's a problem and move on to the next one. So it's just their style of development.
Yeah. So let's go up this way, and we all know what happens here, right? It's about 7 minutes later, so it should be somewhere up here. There we go. Suddenly, there's no Starship left, and right here. What do we think, Marcus? You were talking about, was there a leak during the flight? Because we saw those weird flames coming out the side. We saw the weird behavior on the one Raptor where the exhaust looked like a different color. Potentially on the other side, was it damaged during the, I'm going to use the term hard, landing? And, like the downcomer cracks or the thrust puck fails somehow. But clearly there was
it goes there.
God.
Yeah, it's like, wow, it really did take a second flight there. I'm not sure what the altitude was. It looked to me like it launched itself a good 60, 70 meters in the air. But, the one thing that I saw from other angles, and even SpaceX's angle as well, you could see that there was definitely quite a lot of burning going on underneath the skirt area. There's smoke sort of billowing out from around the aft fins and that sort of thing. So there's definitely still stuff on fire, right? And it seemed to be, to me, almost like that same flame that we see on touchdown, sort of billowing out from the side. It seems to me like there's probably still a leak of methane and oxygen underneath the skirt. And if you almost frame by frame it, you can see that the explosion definitely comes from underneath there. And the one thing that's really interesting, if you look closely, there's one ring section not a ring section, sorry. There's one section of the nose cone that basically just concertinas in on itself. It just completely crumples. So that's definitely the weakest point of the nose.
Look at
definitely
that.
the weakest point of the nose. Yeah. It just crunches up like a soda can immediately. So that's interesting as well. I suspect they'll probably be looking at that thing, thinking, okay, we probably need to reinforce that that particular part of the nose, because I would have expected that nose to survive until it sort of hit the ground, I guess.
Yeah. So clearly, I think you're right about that. I mean, when you get a huge explosion like that, it looks, you see all the stuff that's down here on the ground, right? It's keeping low to the ground. If it was smoke, I would think it would be rising up because it would be warm. But this looks like cryogenic liquid sort of at ground level. We see it almost looks like tank farm venting, right? And it's all sort of hugging the ground there instead of rising up the sides, as I would expect like hot smoke particulate would be. And clearly, when you get a big explosion like that, it looks like there was some mixing going on, right? If we remember SN, what was it, 4, 6? Which one was the fuel air detonation that we saw?
SN4,
SN4. It really looked like there was some mixing going on here. So whether the leak was before the landing or whether the leak was the part of the landing, like it hit and something cracked or a pipe came loose or whatever, definitely there's leaking happening and then some sort of ignition source gets hit. I don't know if I'm ever going to be able to get it the exact right thing. I never remember what the button is to do frame by frame on VLC. It never works.
Oh, okay.
But you can see, let's see here. a huge spurt come out of what seems to be the tri-vents right before the explosion. I'm going to get it. Watch. I'm
Yeah,
probably not
yeah,
going to get it. Look,
yeah, yeah. Perfect.
you see that?
Perfect.
And it's
Yeah,
dark. It's like
yeah,
a
yeah.
dark plume, and it looks like it's coming right out of the tri-vents.
Yeah, and this on the SpaceX stream before they cut away, you can see there's sort of wisps of that quite dark smoke coming out from around the aft fins. So I suspect there's just a fire there that's just slowly eating its way through whatever it was to breach that tank or breach one of the lines, and then boom, off it goes. Yeah,
Jeez. And look at that crumple on the top. Wow, you're right.
yeah. That whole thing, Constantine, is really hard. And there's a great one of the bits of footage I've seen that's like extremely impressive in a slow mo was the one by Cosmic Perspective. You really see that nose crunch in. It's amazing actually. But yeah, it's yeah. I mean, what a day, what a flight, and it was a bit of a marathon. You know, we had the initial abort happen before the flight, and then we were sort of in a two hour holding pattern to see what was going to happen. And luckily, it did fly the second attempt, because I'm not sure I could have done the stream that length again the next night. That was a marathon as it was.
Well, even that in and of itself was an accomplishment, because it wasn't like, oh, we aborted at T-minus 30 seconds and then we're just going to recycle. The engines ignited. There was thrust produced by Raptors, a big plume of dust illustrating that. And then 2 hours later, they recycled after an engine firing.
Yeah, and as far as I know, as far as I know, it was literally just a quick programming change. Say, look, let's increase the thrust allowance for this. And try again. And it's like, wow, the fact that they can just so quickly reiterate and reattempt is insane. It's a testament to to how mature the Raptor already is in that regard, that they can do those tests so quickly. But I mean, obviously they're still experiencing the odd issue. We're still not sure what if there was any Raptor issues, or whether it was more leaks or something in the fuel lines. But each time they get quicker at turning these around, and it's going to be interesting to see how long it takes for SN11 to fly as soon as it's moved to the pad.
Yep, I'm not going to leave it on the flattened. It looked like IKEA got a hold of Starship packing, because it's a flat pack Starship at the end. We're gonna leave this as the SN10 remembrance, not the flattened Starship. As we sort of talk through, Thomas is reminding me over here. Oh yeah, Doss, weren't you going to answer some viewer questions at some point? And now it's 4:30 p.m., which is 4:32, 2 minutes after we're supposed to stop the show, and we haven't even gotten to Starship questions. Which is my fault, because we could sit here and talk about this forever. I mean, looking at footage and just watching the thing fly, that's always a problem we could have. But Marcus, are you cool? Do we have a couple minutes to get a couple questions?
Yeah. No, I'm fine. That's no drama at all.
All right. What else are you going to do on Sunday morning, right?
Exactly.
This is a great question, and this is something that I think we haven't really heard a lot of people talk about. If SN10 hadn't exploded, how was SpaceX planning on emptying the fuel and oxidizer?
That's a great question. Well, yeah, there's no ground equipment to kind of hook up and detank the vehicle, right?
Yeah.
So, I mean, obviously, you kind of plan your fuel load so that you land with as little amount of fuel as possible, with some margin added in. So there's not going to be very full fuel tanks at that point. But the fuel that is in there, you kind of just have to let boil off. I mean, SN10 might have just been sitting on the pad for a day or maybe even more, waiting for the fuel to boil off and evaporate. I don't know what's the long-term plan there. I
mean, they've sort of had this similar issue with SN5 and 6, though, haven't they? Like, I mean, they've landed as well with presumably some fuel remaining. So, what was the turnaround before they could actually get on site to do, the lift? Obviously, they lifted those up.
I suppose that was on the order of like a day, right?
Yeah. It didn't seem that long, and I know there was some of those similar questions. Whether liquid oxygen doesn't matter. You could basically just open up a tap and let that run out.
It wants to be a gas methane.
Yeah, that's right. The liquid methane, maybe not so much, but I know that they. I know that they certainly do aim to land with almost no fuel left, and you see that even at the top of the ascent when they just let the let the liquid oxygen run out of there. They sort of do a liquid oxygen dump. So I think what they're doing is they're timing it so that the main tanks, the methane in the main tanks, are being emptied out almost entirely, and then they say, righto, that's empty. Let's dump the remaining liquid oxygen, any sort of buffer that we had there, just so that they're using just the header tank fuel at that point, and then let it come down. So hopefully there wouldn't be too much. And even if you sort of see the explosion, it wasn't a hugely energetic explosion. It wasn't like SN4.
Right. You didn't see a shockwave. My robot is still in one piece out there. Like,
yeah, that's it. That's it.
Yeah, and you have to remember, and this is kind of, we can tie this into Falcon 9 too, because obviously Falcon 9 has similar scenario where it lands and has some residual fuel left over. Like Marcus said, you can vent liquid oxygen whenever you want. It's oxygen, plenty of it in the atmosphere. That's not a hazard.
Yep.
On a Falcon 9, your other propellant is kerosene, which is stable at room temperature. It's cryogenic, so for Falcon 9, it is going to evaporate and undensify. But that you can have personnel around kerosene. That's not dangerous. It's hard to accidentally ignite kerosene. Methane has got all sorts of different issues. You don't want to be venting methane, much more ignitable. So it's a slightly different scenario. But again, you can vent as much as you can during the flight and land with as little as possible.
Yeah. And I think at some point we'll see like some ground service equipment. GSE. Everybody always asks. The biggest question we get in our videos is what's GSE? It's ground service equipment. I imagine at some point you're going to see a Starship land just fine on the pad with legs version 3 or whatever, and they're going to stabilize it. It's going to be safe, and then somebody's going to go out there with big hoses and ka-chunk and like plug hoses into it or something. Detank it, and all right, we're good to go. Let's get it over here with the crane and. Just, I think there's some ground support equipment that we won't start to see until we start getting successful landings being sort of the norm. To sort of save. But such a good question. I'm going to see if I can grab just a couple more really quickly.
Sure.
I know there's 15,000 super chats and stuff like that. I'm not going to be able to read all of them, but let's see.
Yeah, thanks so much, everybody, for the support there. I mean, NASASpaceflight are the source for this stuff. They're, the guys spending this, the huge dollars on all this camera equipment and stuff. So it's hugely needed and appreciated, I'm sure, by all the NASASpaceflight team. Just from an external point of view, of course, coming in as a guest, but it's the coverage you guys are able to get now compared to what we were able to get, say, 12 months ago is insane. And thank you so much for all the work you do there. It's appreciated by the entire community. Of course, myself. We couldn't do what we're doing without your support. And it's awesome.
To be fair, we do have this cheat code. Her name is Mary. She's kind of out there more hours than there are in a day, and so that gives us a fairly unfair advantage. Poorly, but
And thanks so much, Mary, for all that incredible work. We love you. If you're out there listening right now, it's just awesome.
God, absolutely. Let me see if I can grab one more sort of thing, and this is from Ross saying, "What tweaks to the landing burn, if any, do you think are needed to perfect Starship soft touchdown?" So, do you think we're going to see a change to the trajectory? I mean, we've already gone to lighting all 3 engines. Did one engine shut down? Did it not? Do you think there's going to be anything else we see there?
Well, I think we're going to definitely see landing with 2 engines. And there was a hint in a recent reply from Elon that suggested that maybe they would be trying to land with 2, or at least for the vast majority of the landing, they've got 2, and then maybe they just quickly switch to 1 just for the last final few seconds of touchdown. So I suspect we'll see 2 engines burning for longer next time. For sure.
Thomas?
Yeah, as far as like design changes to the trajectory, I maybe, like Marcus mentioned, switching to 2 engines for a little bit longer, but I'm fixating on this one piece of official info, which is from Elon saying that they had this thrust level problem, which if that's the case, then that's a Raptor engine problem. That's not something you can design out with the trajectory. Obviously, you just got to get Raptor to be more reliable, which will come with time, and this is a test program. It's not really unexpected that they're still working on that. That's really what I'm fixating on as far as what the fix is.
And whether it's Raptor related itself or whether it's more of a fuel pressure feed
or that
issue.
True.
Yep.
It could be the fact. I'm actually thinking maybe the Raptor is actually quite reliable because they've tested them so many times in stationary stand, but it's probably more of a fuel flow problem or a pressure problem, which is what's happened certainly with SN8. So I'd love to hear more information on that from Elon, actually, whether this particular case may have been related to pressure issues or fuel feed issues or the Raptor itself. Yeah, it's speculation at the moment.
Yep.
Oh
It
man, I
did-
love that shot.
It looked to me, and I don't know, you have to sort of go with a context shot for this, where you have the ground fixed and you can sort of see the motion of Starship. It looked to me like it almost wasn't really doing a hover slam sort of thing here. Like, we know Falcon 9 is like, come to a stop at the exact time that you're touching the pad, like this most efficient landing possible. This actually started to look a little bit more like a Blue Origin teeny tiny rocket landing to me, where it comes in and it shows off and it hovers around the pad like this, and then it comes up and lands.
Right.
There seemed to be a lot of hovering here. Of course, decelerating. We see the other engines flame out, and then it sort of really slowly comes down, as opposed to a coming to a stop right
at this point. It's navigating to the landing pad rather than killing its vertical velocity. And so I mean, that's something we kind of expected. You know, it doesn't have this thrust to weight ratio problem that Falcon 9 does, where you have to do a hover slam, and if you burn too early, you're going to have zero velocity above your landing point, which that's a problem. So they don't. Right, you can throttle low enough that you don't have that sort of issue on Starship, which will increase your landing reliability a bit eventually.
Do we know if the flip was done? Do we know if the flip was done at the exact same altitude? Has anyone overlaid the screens from, say, SN9 to see if they flipped any earlier at all?
Oh, geez.
You know, I don't know if I've seen
grab
that.
like a composite shot, but I don't have both of those. I think Jack would have something like that, because we know we've got.
We've got some from this flight. I don't know about previous.
But we'd have to get. It's like, this is Jack's composite. Let's get this.
Yeah, it'd be interesting. Like, if Jack does another one of these for SN10, we could almost directly compare. You know, the altitude. I suspect it was probably the exact same altitude, but because they fired up with the 3 engines, it slowed down heaps quicker. So it seemed like there was loads more time before it comes down. So that'll be interesting to see.
Yeah, the composite shot like this definitely illustrates the S maneuver at the end, where it's sideways, and then it ends up landing well in front of the nose from this angle, you know?
So, it's incredible, really. It's an incredible maneuver that they're doing there. And, you know, with, as you say, some of these things have been done in the past in different ways, but this is a much bigger scale. And and you know, also different, different manufacturing techniques and different metals. I mean, I don't think, these are obviously very massive, made out of stainless steel or grades of stainless steel. These things are not light, and to flip this thing over without breaking it in half is pretty astounding.
And it's also coming off a production line as well. This isn't like one experimental thing made in the skunk works, like hidden in the basement underneath a secret facility, and they made one prototype. There's like lines of Starships ready to go, you know, getting ready to go, I guess is the right way to say it. But that's another big difference in what SpaceX is doing versus in the past. I mean, for me, I'm not surprised that they can land on their tail like this. We knew Falcon 9 could do it. I wasn't surprised that Starship would be able to do it. I think the big thing is the fact that this is a huge vehicle. It's ridiculously huge, and the fact that it sort of scales like that, like, wow, that's really cool.
Yeah, that 50-meter height of that thing is pretty astounding. It's just an astounding stat of its own, and you know, it's going to be bizarre to see it sitting on top of a super heavy. That's that's another 70 meters on top of that. Like, that's going to be beyond anyone's real comprehension. I don't know what the exclusion zone is going to be for that. I'm assuming they probably need to make it a little wider.
There's so much stuff that we haven't even covered. We could have done like 3 hours on Starship alone, and we probably still wouldn't have been able to get through everything. All the different thing. Of course, we saw. I'm just going to like speed run a couple things real quick. We saw the robotic dogs. This is another photo from Jack. Both Jack and Mary were out there showing Zeus prancing around. Of course, that is amazing to see. It's got a little camera thing on top. I'm speed running these. I know we could talk about this for 5 minutes, and we can talk about the next thing. We've also seen some memes on some of the Raptors coming in. I think this is just from today.
Oh yeah, we got another one. They're getting, the folks at McGregor are getting creative with their engine labels.
I haven't seen that one. That's good.
This is hot off the, I guess, pixels, hot off the airwaves, hot off the LTE upload from Mary out there. They put on the blind there, much land where box. Actually, I don't know what that means. I wonder if is that like They're missing the cardboard box that they had
Yeah,
on the last
some
one.
of them come up with like there's like a cardboard cover over part of it, and this one doesn't
Yeah.
have it. I don't know if that's what it is. I don't even know. I wouldn't even begin to speculate whatever that is, but
Is it
it's amusing regardless.
is it
I just
targeting the
find it really
landing
cool.
box?
It's
Like,
it's really
Yeah,
cool.
I don't
Yeah,
know.
yeah. I
I
just find it really cool that there's somebody out there, getting this thing ready for transport or whatever. And it's like, I'd really like to
Breaks
see
out a
this on
Sharpie.
NASA spaceflight. What can you say today? That's kind of going to get a bit of attention, and then all of a sudden we're all talking about it, and all these videos getting hundreds of thousands of views. It's crazy.
there was a picture of the Doge meme on the last one that came through. Not the last one,
Right.
but another Raptor that came through. Just
Yeah.
it's fun. Compare this with like another company that has like the sealed trailer and the super secret nighttime transport, and no one, right? And then here they're unloading this thing from a van. Have you seen the people who drive the van? Just like a couple of people, and it's just an old couple that drives these Raptors back and forth. No big deal. They have memes on them. Like, really? So
Yeah.
it's
Space
cool.
flight
just
in the
so
21st
casual.
century, am I right?
Casual. I like
Yeah.
that. Yeah.
It's just so casual, We saw Raptors earlier coming down on forklifts and all sorts of stuff. It's like, we've got a spare forklift over. Load it up, take it down. Stop mucking around. Get it down there.
Yeah, right. Just across the board, all the cool stuff that's coming out of Boca Chica, coming with the Starship program. I know that we're going to continue to have these spectacles. I'm going to call it a spectacle. These starships launching. We already know that the booster's in there. If we weren't already 15 minutes over time, I spool up a live feed from Boca Chica and I'd show you the picture of the booster, like I like to do. But I haven't done that here. I'd have to go click on two things to make that happen. But we're now 15 minutes over the time that we're supposed to be. We haven't even read a super chat, and I don't even know how long. Just across the board, everybody that came through with all the support today. The Boca Chica Air Force. Marcus, have you heard us say Boca Chica Air Force?
Yeah.
All the
On the
birds that
offhand.
fly around. Yeah, the lines of birds flying over Boca Chica. We're like, oh, there goes the Boca Chica Air Force again. I won't be able to get through all of these, y'all, but if you did a super chat today or anytime, know that we absolutely appreciate your support. We wouldn't be able to do it without you. Hey, also, if you're a member, you're somebody here on the channel every single month, and you got that recurring thing where you're like, wow, I accidentally clicked on this, and it's been charging me every month for NASA Spaceflight. I guess I'll let it keep happening. However you stumbled upon that, we appreciate it. And Marcus, for you as well, folks, really quickly, NASA Spaceflight is a creator team. Marcus is a creator with the creator team as well. Don't you have like Patreon and stuff like that? You do live streams. You're on YouTube. Like, tell us a little bit about how people support you as well. Say thanks.
Yeah. I look, obviously views and likes and subscriptions and stuff all work. I've also got a membership there where you can get ad-free stuff. We do have sponsor placements to help pay for everybody's time and everything.
Yep.
Patreon is all linked in the descriptions. It's all hugely helpful, and it's not money that's just going in my back pocket. It's money that's going out to the developers and the people that we support. We then re-support others on Patreon, especially all the amazing 3D artists. So yeah, it's all hugely beneficial, and thank you so much, everybody.
I'm going to do this. Marcus didn't tell me to do this. I'm going to do this. Here is a link to Marcus's Patreon if you want to
thanks,
support
man.
what he does as well. I mean, we're one of many teams that do stuff. If you like this sort of coverage, you like Marcus, you probably already know him. Make sure you head on over, check out his YouTube, support him on Patreon, buy him a cup of coffee a month or whatever it is. I know it all adds up, doesn't it, Marcus?
Yeah, look, people are surprised. People are like, does a couple of dollars even help at all? It does when it's multiplied by 500 people. It really does. So every little bit helps. Thank you, everybody. And not just for supporting me, for supporting the entire community. It's not just me, it's the other channels. Yourselves, obviously, are critical to this coverage, and likewise other channels as well. So thank you, everybody, for everybody's support. It means a huge amount. We couldn't do it without it. We really couldn't.
Absolutely. Hey, also, you got Marcus on Twitter over there. Let me see here. Oh, I didn't do the crop right at first, but whatever. On Twitter, you're at Marcus House, right? We'll get that link into chat as well. And then on YouTube,
thank you.
also Marcus House on YouTube, just across the board, right?
Yeah. I try to have that keyed in everywhere. We only just managed to switch the Twitter not that long ago. Actually, it was Marcus House Game for a long time, but it's now just Marcus House. So I actually do own both of them, which is good. Yeah. And no,
Excellent.
thanks very much for having me on. It's been a blast
Yeah.
joining you guys. I haven't been in one of these. I have been on another NASA spaceflight live stream before, but not one of these
Yep.
more weekly update ones. So thank you. It's been awesome. It's been a real blast.
Absolutely. We'll have to have you back in for one of the Starship streams or something like that. Get you
Yeah,
connected for a
yeah,
test or something. Always
yeah.
a
That'd be
pleasure
awesome.
to hear from you. And again, Marcus, thank you for all the work you do bringing space down so that more people can enjoy it. Just getting the word out, especially with the awesome accent. I like the accent.
Ah, thank you. Yeah, yeah, yeah. The accent, the Australian accent, may not be for everybody, but but yeah, no, we've got a good following all the same. So yes, and although I will say, NASA spaceflight has accelerated into the stratosphere on from a subscription point of view. So I'm kind of waving you off in the distance. Bye.
No. Hey, we have a lot of fun with what we do, and we're so glad that so many people show up and enjoy it. So that's all we can say, folks. Again, this is Marcus House, another fantastic. I don't even know what the right terminology. Space friend.
Space tube up. I don't know.
Space YouTuber. I don't want to call you like a content creator or a YouTuber, like one of our friends. Let's put it that way. If you
Yeah,
like
thanks,
following
guys.
space, you're excited about Starship or SpaceX or whatever, all the videos and stuff that he makes. Make sure you check him out over there. Also on the stream today, we had Thomas Burghardt, who probably has to go. He hasn't been frantically waving at me like, "Hey, we need to quit the stream. I've got a hard stop at like 5 minutes ago."
I mean, hey, the longer I'm here, the longer until that Peter Beck article gets published. So that I guess was just, but no, just a huge thanks to Marcus for hanging out. Always fun talking to him and talking about Starship and all the stuff that was going on. NSF Live, always a great time. So thanks, guys.
Thank
Absolutely is.
you.
Yeah, and Thomas, thank you so much for joining us here today. It is the end of the stream here, though, folks. So whatever you've done, I know that there's tons of questions we missed. I know that we can't read all the super chats. Hey, members, thank you so much for the support and everything you do. Across the board, we just appreciate everybody showing up to these sorts of live streams, events, whatever you want to call them. I don't even know anymore. But we are out of time for today. 21 minutes over on NSF Live here, usually an hour and a half, and we're in an hour and 50 minutes, 50 minutes. So we do need to go ahead and shut this down. But for now, Marcus, again, thank you so much for joining us. Thomas, as well as always, good to see you. I'm John Galloway for NASA Spaceflight, and we will see you nerds next time. Thanks for everything you do to support all the creators across the board. These are exciting times to live in, nerds.
Thank you, guys. We'll see you soon.
All right.
Propulsion continues to be normal.
Alright, the chamber pressure looks good. Following up. Roger, roll, Atlantic. Flight outside of speed off. Speed off.
Yikes. You bet. Concur. We don't need any more of these.